It's been a long night, and Ops is here to be the nightcap. Put everyone to sleep. We got a great talk on setting up a development environment with Docker Compose. It's really just setting up anything with Docker Compose. This doesn't really necessarily have to be a development environment. This is just how to use Docker Compose to make something, really. So who here's actually used Docker before? All right. Who here's used Docker Compose? A couple, right? So Docker defined is a way of packaging your application into a standardized unit for software development. That's one way they describe it. Another way is a Docker container wraps a piece of software and a complete file system, along with all of the system tools, the runtime, the library, everything else you would need to be installed on the server when you provision it, and guarantees that software will be run consistently on different environments and different systems. I like the second way of thinking about it because it's just easier. It's more finite to think of it as like it is all of the things you need put together and in a way that you can move it, that's portable between environments. What is Docker Compose? Compose is a way of running these like individual processes which you put in a Docker container into multi-container systems. It's about arranging those containers, like the different ways you would, the different pieces of your system, arranging them into a logical service, which outlines all the dependencies that need to be in existence and running, and make sure they're booted and there for when you go to use it. So why would we use it? There's a lot of other things you could use instead, like I use Homebrew. Yes, the answer is that works fine. That works for some things, but Homebrew's best use case is if you're working on kind of like the same, for your development environment, if you're working on the same application daily and you deploy to any non-Docker production environment, then that's probably going to be the path of least resistance for you because it's not involving a VM and there's complication and overhead. But it also misses out on some key benefits that you would get, like disposability and reusability. But what if you want the disposability and reusability without Docker, like a regular VM or Vagrant? Those will work, but with the VM, you lose the quick disposability of a Docker container, and with Vagrant, you get that back, but you lose, there's a lot of overhead to running multiple Vagrant systems, if anyone's done it. If anyone has had a multi-VM environment with Vagrant, there's a lot of overhead. So it comes down to that one question: do you intend to use Docker in production at some point, or really value the disposability and reusability? If those questions are yes, then I think that's the appropriate path to follow to try to set up an environment. So let's look at what like a Docker file looks like. Okay, everyone see it? All right. So no, just kidding. We'll go back. What I like about Docker files is they're very simple to read, and it reads really easy. This is basically just saying it's using a public repo Ruby. So it's saying like take a base image Ruby, the version of it 2.3.3, and then run these following commands. Add a couple things, change your working directory, and then run another command. You could provision a system, then go back through your bash history and basically extract the parts you would need to write the Docker file. That's pretty nice. One good question to ask is why would you split out all the individual installs there? You could just put that in one line. Well, Docker does something clever, and it caches the result of each line of a Docker file. So when you build this, it's going to run and then cache the results of each line. So if you change the last line, it doesn't have to redo all the previous lines. It just loads up the base image, applies the new change, and passes down. So that's how you can quickly iterate on the Docker file without rerunning the whole thing every single time. It's really convenient. So if we run that Docker file, we're using Docker compose build. We'll see that later again, but that's going to build that Docker file. And basically the first lines you see there are it pulling the cache from the Ruby image. So if the base image that you are changing changes, you only pull the changes to that base image. So you're not if the base image changes, you're not pulling the whole thing every single time. It saves a lot of bandwidth and a lot of time. It's really convenient. And it's going to run through, and you can see the individual lines of like what it's doing each time. It goes on forever, so I just truncated it. So what happens if we change the Docker file and then rerun it? Well, we'll like zoom in on here. You can see that there's the previous lines, it just caches them. So it takes no time at all. It just says using the cache, using the cache, using the cache. And then it gets to the line that we added and then applies that change and then updates the container. Okay, so we've built one Docker container. This container happens to be a Ruby container. Now what? What do we have? We have just one container that has Ruby. Let's try to do something with it. So we're going to use Docker Compose. We're going to create a file called dockercompose.yaml and specify the API version we're using, and then specify the service. In this case, the service is web. We're going to add our current directory, because this file is just going to live in your Rails app. Say this is a Rails app. It's going to live in the directory alongside your gem file and any other blank files you have in there. You're going to mount that directory inside the container and then run a command. In this case, bundle exec puma, which is going to boot the Rails app. There's two commands down at the bottom. I kind of showed those there's expose and ports. Expose, basically that. You don't need both of them. I did it here for just to show. But expose will expose internally to Docker a particular port so that other containers can connect on that port. And ports deals with what internal port in the container is exposed to the system. So in this case, I'm using 3000, which just means that I can connect from the local machine on 3000 and reach into the container on 3000. So we run this. Oops. Rails app. This is an error that just, I kind of was torn on putting it on there because it just gives me chills. I can't connect a local MySQL server. You see this? Not good. Not good. Especially in your production system. Sorry, Jeff. Yeah, we need a DB. So let's actually use use Docker Compose to build a system. So we're going to add another service. In this case, we're going to add a database service. We're just going to pull MySQL from the community MySQL, and we are going to expose the ports 3306 to ourselves so that in this case it wouldn't matter if I took out that first 3306 and ran Docker PS, which just describes the running containers. On the bottom there, under ports, there's 3306 and then some long number, 32769 in this case. That's because Docker, if you don't say expose this port to the local machine, it's just going to pick a random port, and it'll change every time. So I set an environmental variable, in this case, just to allow the MySQL to not have a password. And then The important thing there is the depends on DB, which basically says this web service, if someone launches it or runs a command specifying it, also launch the database because it can't run without the database. That's kind of how you build a web of dependency and allows one-off commands to actually make sure everything is in a state needed to run. Let's see. Yeah. We also, though, in order to get the thing running, we have to make some changes to database.yml. This is not Docker Compose specific. This is just Rails. But there's one important piece in here that I want to show that kind of ties together some things about how you would build a system using Docker Compose. And that is where it says host and it just says DB. That's because the instance or the service name for our database is DB. And basically inside a container, you can connect to any of the other containers through their service name. So just by specifying DB, it's gonna, through a DNS lookup, know what the internal IP is for that Docker and then connect. And you don't have to worry about any of that. You just have to know what the service name is. So as you make those changes and then run one more command, down there at the bottom, Docker Compose run. I'll talk more about that command later. It's going to go ahead and create the databases, and then, ta-da, you will have a running Rails app. If you notice the 127.0.0.1, that's the IP you connect to the Docker machine on. Okay. Now that it's running, let's see some things that you would typically do every day if you were using a Compose, if you were using Docker Compose for your development environment. Build. Every time you change the Docker file that for either of your services, you would run build, which will just rebuild the Docker file basically. Docker Compose RM, removes a container. It's like deleting. This is what gives you the disposability, like of just tossing a container and I'm gonna recreate this. Something's weird with it. I'm just gonna, Docker Compose RM it. Up and down. Up boots everything. So that's what you do when you first start everything up. Down is like running remove on everything. It just deletes your whole stack. Primarily you would use Docker Compose start and stop. So once you've upped everything, you can just stop your stack if you're done with it and then start it back up again. Run. Launches a container and then runs a command and then discards the container, basically shuts it down. So you would use this to just run a command, basically. And then exec is like run, but it's slightly different in that it tries to attach to a running container and then execute inside of it. So that's more for debugging. If you're trying to figure out the state everything is in, you would use exec. And logs is what you would do to get a nice -F to follow, but logs would be a nice long list of everything that's going on standard out inside your containers. I've battled with Compose a little bit, so I have some tips from real world usage. I'm going to save you hours right now. Hours. Don't put environment-specific config in the base image, and try not to make environment-specific images. So the goal is to get the most out of it. What you really want to do is have a single image that you can transport from development through to production, through test, through CI, through all of that. So try not to bake in specific things to the container itself. You'll want to use environmental variables to set up the specific environment-specific aspects of it. This ties into make sure individual containers are disposable. Well, that sounds similar to what I said, but it's kind of different in that this means just make sure that there's no state inside the container that will break things if it goes away. So keep everything replaceable, basically. And utilize the community containers like the MySQL, like the Ruby that I was just doing, but feel comfortable creating your own if you want to use a specific container all the way through production. This kind of, you should feel comfortable enough to make your own containers. But feel free to utilize the community ones. They're great. And if your Docker Compose file is getting really complicated and long, you can use something called extends, to break it up. And basically what you would just do is like create 2 files and then create a new service that extends the other service, like inheritance we just saw. And then include both those files when you run the commands, basically. Let's see. All right. So the big concern is if you're using Docker for Mac, be prepared for slow performance of something called OS X FS, which is included with Docker for Mac and handles the native file, the native file system volume mounts. So earlier when we saw, like, if I were to specify a volume in a Docker container, OS X FS is the system in which those files are moved inside the container. And if you use a lot of small files like Ruby gems or npm, it is maddeningly slow. Like, it will make you angry. Like, how angry will it make you? It'll make you, let's see, it'll make you angry enough to actually yearn for NFS, which some people get it. That's bad. You know, probably angry enough to hammer out an angry tweet on your Android phone at 3 a.m. Like, angry enough to pour a tall glass of scotch and read a whole year-long dialogue in this thread. You can see it's the original bug report about OS X FS being slow and CPU bound. And like, the original date on it is March of 2016. So we're almost a year in. And I don't know if any developers has ever indulged in reading the full extent of a year-long complaint thread. It is a treat. It's amazing that, like, towards the end of it, people still thought there were things that hadn't been said at that point. They're like, my opinion on this must be heard. Sorry, Docker, I give up on you. But there, you know, inside there are pretty good write-ups on understanding from the Docker employees on understanding what the problem is and steps they're going to take to fix it. Hasn't been fixed yet, but that would be a big hang-up, especially if you want to use Docker Compose for Rails applications, or like I said, or like Node. You know, npm is going to take a long time to run. Bundle install is going to take a while, etc. There's solutions, though. You can use NFS. You can switch the Docker machine from the native one that comes with Docker for OS X to something called Dingy, which is just a replacement VM. It supposedly has better performance. You can use local drivers. That's basically what that is. It's like it's a mount inside the container that it treats as native. So you don't sync. There's no sync. It just writes to it inside. An example of using that would be, if you see down at the bottom there, I'd specify a MySQL data, and then I'd mount that where the MySQL data would go. Basically, if I run a Docker Compose down and get rid of that entire stack, that volume of data will still live on. So you won't lose your development environment data. You won't lose your MySQL data, and you can spin the whole stack back up and everything will still be there. That's a neat trick that would have saved me a lot of time. Another one is Docker Sync. Docker Sync is something you can download from, you can see dockersync.io. It's a Ruby gem. Basically, it sets up a syncing container, uses a tool called Unison. You know what Unison is? It's bidirectional sync. So things that change inside the container will sync to your machine's file system, and changes you make will sync inside the container, and they'll have file events and stuff. That's the big pain with like using NFS or any of those ones, is they don't have, like, when you save a file inside the container, it doesn't realize you saved the file. It knows the data changed, but it doesn't know that the file has changed itself. That's why things like, if you're in the Ruby environment, like guard and stuff like that don't work. But with this sync, it does. So it's kind of nice. But it's one more thing you have to run on top, but it's really fast. So that was pretty dense. I know it's tough to go last with such a dense talk, but hopefully there's enough value in there that you can look through the code samples and put together a quick environment, especially if you have small Rails apps that you're spinning up that you want to go back to. A good thing is if you ever have to go back to it like a year later, you don't have to reset everything all up again. You just run compose up and it comes back. If you've ever had to do that with like something you're working on homebrew, you're like, I don't even have the Ruby version installed anymore. I gotta reinstall the Ruby version, gotta reinstall this stuff. So that's it. Hope you enjoyed it. Thank you. I do have questions, but I'll take them in person afterwards because we're long.